In this video, we're looking at two setups of electrolysis of water. I'm just doing it twice to collect gas for two different classes. So I'm going to zoom in on one of them and just take a closer look. This is for grade 9 advanced science. We can see in the beaker, a beaker that's about half full of water. That's just tap water. And there are two test tubes inside, inverted. Now it's hard to tell in the video, but the two test tubes are full of water. They were originally stoppered and the stoppers removed. You can see that there's two electrodes. Those electrodes are coated in blue rubber and they're connected with alligator leads here. The two electrodes are in the mouths of the test tubes. You can see inside the test tube there's the mouth of the test tube, there's the bottom of the electrode. Notice that some of the metal part of the electrode, the exposed metal, is below the mouth of the test tube in both test tubes. That allows electricity to flow between the metal electrodes in the water. Now the leads go from the electrode attached up there with an alligator clip down back over here to a power source. And this power source is showing that I've set the voltage to be 8 volts. But right now you'll notice that there's no current. The current is showing to be 0.01 amps. So meaning there's very little electricity actually flowing through this system. And that's evidenced by the fact that there's really very little evidence of reaction. If you look really close, you could see perhaps in the test tube on the left a few bubbles of gas rising, and on the right a slower, but there's a few bubbles of gas rising there too. The problem here is that water is not a good conductor of electricity. So even though we're trying to do electrolysis of water, we're trying to break the water into its elements, right now it's not really conducting electricity very well. So I've got here a beaker that contains a salt solution. This salt that we're using is sodium carbonate, carefully chosen. You can't just choose any salt for this. So we're going to use washing soda, sodium carbonate. I'm going to just add some to the beaker of water where we're doing electrolysis. Now, as soon as I add that, sodium carbonate, washing soda, now looking closely, you can see there's lots of gas bubbles forming at each electrode, rising up the test tubes. Looking over at the power pack, we can see now that the current is 0.12 amps. So it used to be almost zero, now it's 0.12 amps. I'll do the same thing on the left-hand beaker where we have a similar setup. We'll add some washing soda to that. And we notice again that the current is dramatically increased. We can evidenced by the bubbles forming at each electrode. Over on this power pack, we've got a current now of 0.16 amps. On the original one, I've just added a bit more salt solution. Our current is up to 0.17 amps. So now in both beakers, we have a significant rate of reaction. The water is being broken apart, the compound H2O is being broken apart into its elements, hydrogen and oxygen gases. We'll let this run for a few minutes and then we'll check back on it. So the experiment's been running for about 3 or 4 minutes. And if we just zoom in, we can see over here on the power supply, the voltage is up to still 8 volts and the current 0.19 amps. I confess I added even a little bit more salt water to it. Now if we look over here at the bottom of the test tubes, we can see again the high rate of gas production. But do you notice the test tube on the left seems to be getting more gas produced than the test tube on the right. The bubbles on the left seem to be at a faster rate than the bubbles on the right. If we scroll up here and look at the top of the test tubes, that's evidenced by the fact that there seems to be more gas collecting on the left than on the right. We're collecting the two gases here by water displacement. One of the two gases is hydrogen gas and the other is oxygen gas. Think of the formula for water, H2O, or think of the balanced equation we wrote in class for the decomposition of water. H2O becomes hydrogen and oxygen gases, and see if it makes sense to you that we're getting more gas in one test tube than in the other. In fact, it appears, just to the naked eye, to be about twice as much gas on the left as there is on the right. So we'll leave this again for a few minutes and we'll come back and we'll check again on it. So we're back. It's been about 40 minutes of letting the experiment run. Looking at the beaker on the left, it actually finished just a little bit before the beaker on the right. In this system, you can see the test tube on the left is about half full of gas, while the test tube on the right has just filled with gas. So I'm going to stop it now before it starts having gas escape from the bottom. So I'll just turn off the power, and you can see hopefully the bubbles stop forming. So we've collected here 2 gases by electrolysis of water in one test tube on the left, half full of gas, and the test tube on the right, completely full of gas. I'm now going to use the rubber stoppers you see at the bottom of the beaker to stopper the 2 test tubes and remove them in order to test the 2 gases with wooden splits. So I've got one of the test tubes, the one that was half full of water, and so it's half full of gas actually, I should say, and I've got a flaming wooden splint. I think that this gas is oxygen gas, so I'm going to take the stopper off and blow the flame out and put it into the gas while it's still glowing red. So the test tube has been unstoppered. We'll blow the flame out and now put it in the gas. And notice that it relit on fire when inserted in the gas. We'll see if we can do it one more time. Blow the flame out, put it into the gas, and look at it reignite in the test tube. Okay, so it reignited into the test tube of gas, which means that gas was oxygen gas. So we filled the test tube half full of oxygen gas. The second test tube upside down, full of gas, and I'm going to put a flaming wooden splint in its mouth. And you heard a big popping sound with explosion, which is the confirming test for hydrogen gas. We'll try that one more time with another one of those test tube, and we'll try it again with the flaming splint. And you heard a satisfying popping sound that time, not just the exploding gas, but the popping sound characteristic of hydrogen gas exploding. So the test tube on the left, which was half full of gas, what turns out to be oxygen gas, confirmed with a glowing wooden splint that reignited when inserted. The test tube on the right, full of gas, was hydrogen gas, confirming that with a flaming wooden splint that caused the characteristic popping sound. So electrolysis of water produced 2 test tubes of gas, a full test tube of hydrogen, and half a test tube of oxygen, so a 2-to-1 ratio of volumes, hydrogen to oxygen.